A function is like a special machine. You put something in, the machine changes it, then you get something out. Think of a vending machine. You put in money, the machine gives you a snack. In math, functions work with numbers. You input a number, the function changes it, you get a new number. Each input has only one output. This is important to remember. We see functions every day. Let's look at some examples. The price of apples at the store is a function. The input is the weight of the apples. The output is the total cost. The temperature outside changes throughout the day. That's a function too. The input is the time of day. The output is the temperature. Even baking a cake involves a function. The input is the ingredients and baking time. The output is a delicious cake. We use special symbols to write functions in math. Don't worry, it's not as complicated as it looks. We often use the letter F for function. We can also use other letters. Let's say x is our input. We write fx to show the output. For example, a simple function might be fx equals x plus 2. This means we take the input, x, add 2, and that's our output. Linear functions are like straight lines. They have a constant rate of change. Imagine driving a car at a steady speed. This is a linear function. The input is time. The output is the distance traveled. Linear functions are used in many areas. They help us understand relationships between things that change at a constant rate. Section 5. Quadratic functions. Curves in the road. Quadratic functions are different. They create curves, not straight lines. Think about throwing a ball in the air. The path it follows is a curve. This is a quadratic function. The input is time. The output is the height of the ball. Quadratic functions are useful for describing things that go up and then come down. Section 6. Functions in the real world. Functions are everywhere in the real world. They help us understand how things work. Architects use functions to design buildings. They need to calculate the strength of materials and the effects of gravity. Doctors use functions to understand the human body. They use them to measure heart rate, blood pressure, and medication dosage. Even video game designers use functions. They use them to create realistic movements and interactions in games. Section 7. Functions in science and engineering. Functions are essential tools in science and engineering. Physicists use functions to describe the laws of motion and gravity. They use them to understand the universe. Engineers use functions to design bridges, airplanes, and computers. Functions help them create safe and efficient structures. Functions are the language of science and engineering. They allow us to model and solve complex problems. Section 8. Functions in economics. Economists use functions to understand how economies work. They use them to study supply and demand, inflation, and economic growth. Functions help economists make predictions about the future. They use them to advise governments and businesses. Understanding functions is important for anyone interested in finance or economics. Section 9. Functions, the building blocks of understanding. Functions are fundamental to mathematics and many other fields. They are the building blocks of understanding how things work. By learning about functions, we can make sense of the world around us. We can use them to solve problems, make predictions, and create new technologies. So the next time you see a function, don't be afraid. Embrace the power of this important mathematical concept.